All right, this is the remainder of section 1.6 on solving quadratics. And so we're going to continue. Last video we talked about solving quadratics by the square root method, the factoring method, and the quadratic formula. Keep in mind, anytime you're solving a quadratic, you're not only finding the solutions, they're also called your x-intercepts, and sometimes they're called zeros. So basically, those are all words for finding the same thing of when the equation equals 0. As I mentioned last video, on a quiz or a test, you will need to be able to solve a quadratic by each of those three methods. You will also be given some quadratics that you can solve by whichever method works or whichever method you are most comfortable with. So we'll practice that with these two. So right now they do not look like they're quadratic, but as we've solved problems like this earlier in chapter 1, we want to get the x out of the denominator. And so in order to do that, we're going to multiply both sides of the equation by x. On the right-hand side, or excuse me, the left-hand side, you're going to get x squared plus x equals, this will allow the x's to divide out, because remember that's like x over 1. And so then it's just equal to 1. So solving a quadratic, I can't use the square root method because I have this linear term. So therefore, I have to set it equal to 0. And now I have the choice of whether I want to try to factor if it does or just jump to the quadratic formula. And so if we were in class, I'd let you mess with that and see which way you wanted to do it. So I am going to use the quadratic formula because I don't think it's going to factor. It's kind of difficult to get numbers that multiply to give you -1, but then add to give you +1. So we know A's 1, we know B's 1, and then I got C's -1. So I'm going to use the quadratic formula. If you did the problems last night, then you have had to practice with the quadratic formula. So I'm not going through a lot of explaining here. I'm hoping you are able to follow me in remembering what the formula is, remembering the A, B, and C, and plugging those in. All right, so I'm kind of running out of room down here. We'll see what I can squeeze in. So it looks like I have 1 plus 4 all over 2. So my final answer looks like -1 plus or minus the square root of 5 all over 2. And so one of the things, again, just kind of reiterate something we've discussed from this chapter before, is because you have an x in the denominator, remember this is a rational equation, so there are certain values for x that won't allow this equation to work. And in this case, x could not be 0. Well, fortunately, 0 is not one of those options. So both of those are legitimate answers for that equation for x. All right, this next one, it's kind of difficult to see. Let's see, we'll go ahead, and I think we can still see it enough to go for it. We've seen problems like this before. So again, we could multiply so that we get rid of the denominator, or write equal denominators and then get rid of them. But I'm hoping we're to the point that you've seen this enough that if you have a fraction equal to a fraction, we know that this is a proportion. So I'm going to go ahead and cross multiply. I'm going to take the means, which that's what we call the down direction, the down diagonal, or the means. And that should equal the extremes, is the up diagonal. And I'm going to have to FOIL because I have two binomials here. So we'll go ahead and make sure we don't lose anybody. So x squared, multiplying the outs, multiplying the ends. We get -3, excuse me, just get 3x squared. Combining like terms, these are going to cancel. All right, so this quadratic, again, you have options, but I notice that I do not have a linear piece. I don't have just a plain x. And so I'm going to go ahead and use the square root method. So I'm going to subtract my x squared so that I can get my x's by themselves. Today's an afternoon of mistakes for me. I apologize. So we end up getting 2x squared equals negative 1. Right? So I'm going to divide by 2. And I get x squared equals negative a half. All right, and so we can go ahead and solve this. In the real world, we're not going to get an answer because you can't square something and get a negative result. But because we're in algebra and we are supposed to show that I have 2 answers, my 2 answers that I have will end up being imaginary. So then I have that x equals plus or minus, because remember we need to show that we have the 2 answers, and anytime you solve by square root, you need the positive and the negative. You have a square root of a half, so, a negative half. The negative under the square root tells me there's an I in my answer, and then I have a square root of a half. All right, well, unfortunately, I'm erasing some of this to give myself some room, so I apologize that some of it's gonna be gone. But this is not a simplified answer, because technically what we have here is we have plus or minus I. It's the square root of 1 divided by the square root of 2. Well, square root of 2 in the denominator is not simplified. It's not what we call rationalized. So you should actually rationalize the denominator. And so to rationalize that means you can't have a square root in the bottom. So I want to make this a perfect square number. Well, in order to make it a perfect square, you're going to have to multiply by itself. But what you do to the denominator, you in turn do to the numerator. Because if you notice this value right here, square root of 2 over square root of 2, it's really just 1. So I'm only multiplying the equation, multiplying this value by 1. And when you multiply by 1, the value doesn't change, just the looks in this case. And so when that happens, we end up getting plus or minus square root of 1 times the square root of 2 is square root of 2. Square root of 2 times the square root of 2 is technically the square root of 4. And the square root of 4 is 2. And so these end up being your 2 answers for x. Try not to divide, do not divide that 2 into this 2, because remember this isn't a regular 2, it's the square root of 2, which is a decimal, 1.7 something. And so there we have it. Checking again just to make sure this is a rational equation. The numbers that would not work would be 0, and then in this problem negative 1. And 0 and negative 1 are neither one of my answers. So those are good answers. All right, so let's look at some application problems. We know, looking into this, that's going to be of quadratic type. And so let's see what we have. Oops, sorry, you don't want to see my email. All right, so we have the demand equation for a certain product is P equals. So this is my demand equation, where X is the number of units sold per week, and P is the price in dollars at which each is sold. Write an equation for the weekly revenue in terms of X. So that just means it's going to be R equals something involving X. Given that the revenue equals X times the P. Use your equation to determine how many units must be sold to produce a weekly revenue of 175,000. All right, so if R equals X times P, my revenue is supposed to be 175,000. X times P, well, they've told me P up here is 40 minus 0.001x. And so now I have an equation that I could solve for x. So 175,000, distribute my x, shows me that I have a quadratic because I have a linear term here, I'm going to need to set it equal to 0. I also like to rearrange it again so that my square is first, linear is next, and then my constant is last. And so here is a quadratic that you get to choose to solve by either the quadratic formula, factoring if you would so be inclined. I wouldn't choose that path. And then we know the square root method won't work. So I'm going to leave you to solve that. Mainly, this video, I'm concentrating on you setting up and understanding what it's asking for in the problem. All right, so let's talk about the skydiver. A skydiver steps out of an airplane at 5,000 feet. How long will it take the skydiver to reach 4,000 feet? All right, so they help us out here and they give us this formula. And we know that the height S is in feet. So I know S, capital S is a height. I'm going to jump over here. So capital S is the height. S, we call that sub-ot. S sub-ot is the initial height. So the beginning height is S sub-ot. The height throughout the skydiver jumping is S. And so what we're interested in is the skydiver steps out of a plane at 5,000 feet. So that's his initial height. And then what we're looking for is when he's going to reach 4,000 feet. All right, so let's see what else we have. The negative 16t squared, because t is time. And it is asking me how long, so that is a time, so I know that's my variable. And the last thing it says where v is the initial velocity. All right, well, velocity is a directional force of how the person is falling out of the plane or getting out of the plane. So if a person were to jump up out of the plane before they skydive, then it would be a positive number. And then it would depend on the force in which they jump out of the plane. Or if they are jumping out of the plane, jumping down, again, that would be a negative direction. So it would be a negative velocity depending on what force they're using to push themselves down. Because in this problem it says that the skydiver just steps out, then really they're saying that there's no force behind it. And so we're going to say that it's a 0t right there. So because that's 0t, I do not have a linear term, and so I'm going to solve by square roots. Actually, I'll let you do it if you want to, but square root would be a good way to solve that. All right. And so one of the other things I want you to think about is that using a graphing calculator is a good way to solve the quadratics, or at least to check your answers also. And so as we wait here for my graphing calculator to come up. All right, so what I'm interested in, well, is making sure this works. Okay, well, all right, maybe I'm not going to use my graphing calculator. All right, so what you would want to do if you're going to use the graphing calculator to solve this is you can put the right side into y equals. So that's annoying me why that graph won't work, but I don't want to try and figure it out while I'm on video with you. So we can put this into y1 into your graphing calculator, and you can put this into y2. And so you're going to end up with a parabola for the y1. And your y2 is going to be y equals 4,000. It's going to be some kind of a horizontal line. And so then what you're looking for is how long it will take. So the intersection, so it'd be here and here. So then you can see that there are going to be 2 points that we're going to reach the 4,000 feet in the entire graph. You're probably going to end up with one of these being negative, though. And so you need to think about, because the skydiver is just jumping out of the plane, we're only worrying about this side of the picture, not the entire parabola. And so if, here's where his airplane, and if he jumps out, then this is the time that we're looking for. All right. So again, I'm just trying to revisit some word problems we did back in section 2. I know it was your favorite one. But using that knowledge and then putting it with quadratics will help us with some of these problems. So a football field is 100 yards long from goal to goal and 160 feet wide. If a player ran diagonally across the field from one goal line to the other goal line, how far did he run? So we know that your width of your field and your length of your field is making a 90-degree angle. If you're looking for the diagonal, then that's really your hypotenuse of a 90-degree angle. I'm hoping that you do draw pictures, because as I was drawing this, when I read it, I didn't really pay that much attention, but as I drew it and I put yards here and feet there, that helped me realize, oh, I've got an issue. And so I'm going to go ahead and turn this into feet. We know that there is 3 feet in every yard. Therefore, there would be 300 feet in 1 yard, or 300 feet would be your 100 yards. And so now, because we're looking for the hypotenuse of a right triangle, I can always do Pythagorean theorem. And again, I'm going to let you go ahead and solve that one yourself. All right, lastly for word problems, we have Imogene. Imogene wants to make an open box top for packing baked goods by cutting equal squares from each corner of an 11 by 14 piece of cardboard. She figures that for versatility, the area of the bottom must be 80 inches squared. What size squares should she cut from each corner? All right, so let's color code things here. See if we can help that. We have an 11 by 14. And I know that the area of the bottom is going to be 80. And I'm going to get the bottom by cutting a corner out from each. So let's just say we're going to cut a corner out here, and we're going to cut a corner out here. And so they're equal. And so I don't know how much I'm going to cut here. So I'm going to give it X, but I cut the same amount over at this end, X. So let's take a look. This original side was 14. All right, but I'm cutting off this end and this end. And so since I'm cutting those off, what does that leave this to be? What does that leave that to be? Well, there was 14 there to begin with, and I'm subtracting 2 X's off of the ends. All right, so let's look the other way. He says I'm cutting out equal squares, so I also have to cut something here, and I'm going to end up cutting it here. And so again, it was 11 originally. So how much is this going to be? All right, it'll be 11 minus, now because they're equal squares, that meant whatever I cut here, which is X, I'm cutting the same here, so that's X. So then it's 11 minus 2X again. And then if you go around and do that to all the ends, that's how you're getting the 80. So really all we're working with is this inner rectangle. And so it's talking about area because I have square measure. So area of a rectangle is length times width. area is 80, the length is 14 minus 2x, the width is 11 minus 2x, and so then we'd need to solve that for x. This is similar to a problem we solved in the last video where you're going to have to FOIL this. And then once you FOIL it, you want to subtract the 80 over so that you can set it equal to 0 and solve. So I'm going to, again, the solving part we did last time. So I'm going to let you mess with solving. I do have note that we could be finding this on the graphing calculator because remember when you are finding the solutions, so if you're finding the solutions, you are also finding the x-intercepts, which on the calculator, the graphing calculator, they're known as zeros. So I'm going to give this a one more shot to see if it's going to play nice. It's it's showing down here, but it's not showing on what I want my screen to show. So I'm not sure why it's not doing that. All right, I give up. I'm going to mess with this on my own time and not take more of yours. So with that said, let me click to the homework. All right, so this is the entire assignment. If I remember correctly, you should have already done the 6 through 27 by 3s. So that should be done. You should have already done, okay, you did part of this. So what you're missing out of here is the 63 through 96 by 3s. That's what you still need to do. And, well, actually, hold on, let me change that. You need to do 63 because I already assigned you 66 and 69. And so then you can pick up at 72 through 96 by 3s. And then the 106 to 110 even. All right. So this is what you are doing if you had already done what I previously assigned. If you did not do what I previously assigned, you get the whole thing. This is all due at the beginning of class, next class period.